afternoon, everybody. How are y'all doing? So there's going to be this presentation is going to be a bit like an onion. There's a story wrapped up in a story wrapped up in a story that I want to share with you. So first of all, just to introduce myself, for those who I haven't spoken to over the last day and a half, and it's been great meeting you all. My name is Carl Dempsey. I'm Vice President of Solution Engineering at Salesforce.com. That sounds really impressive. My wife still thinks I'm second in charge of the company or something, but if any of you know Salesforce, there's about 1,000 vice presidents in the business, so it's not really that important at all. I just seem to give it out. So I started in Salesforce in 2004, so I'm actually disappointed to hear there's someone here who's been involved since 2002. I normally, yeah, well done sir, thank you. Normally I sort of get that credit. Basically my entire career in Salesforce has been in what we call solution engineering, which is pre-sales. So we're the ones who sell the visions and the dreams, and then you're the ones that make it happen. So thank you. Thank you very much.
What do we say about this?
Yeah, I think it's a beautiful thing. We're all one Hannah, right? Just for context, I actually, about 18 months ago, I had this amazing idea that said, it's too hard to try to hire these people from Oracle and SAP and Microsoft. We should make our own. We should hire graduates. And someone said, Carl, that's a brilliant idea. Go do it. So since this February, I've been running a graduate program where we have a first crop of 20 going through pre-sales and 80 going through our CSG organization. And come September 3rd, the next 30 are going to join that program. So it's kind of really exciting, different world that I'm in. So this was kind of fun. So this is the first part of the story, is the fact that, you know, I was talking to Kerry and Sean and Marcel about this 3-4 months ago, and going, yeah, we should totally have a session on Einstein. I've got these amazing people who'll help me put it together and run it and all of that, and you know, I'll be sort of the project manager. And they all went, yeah, Carl, we'll totally help you, the Salesforce people. And about 10 days ago, I said, okay, guys, we're ready. They're like, oh, I'm on holidays. And so suddenly, it falls on my shoulders. So one of my sort of opening gambits was, you know, I think this is very true of Salesforce in general, okay? This famous quote from Sir Isaac Newton, really, I think we're all standing on the shoulders of giants, ultimately, and I know I certainly am. But particularly in the case of AI and Einstein Vision, I'm positively standing on the shoulders of giants, because literally 10 days ago, I knew the sort of the 2 slides in the Salesforce positioning deck on it, and that was it. Suddenly I'm like, oh Christ, I've actually got to know this stuff. And so I sat down with a solution engineer called Philip Moore, who worked on the deal we're going to talk about in a while. And you know, Phil in a morning got me to the place where I'm building object detection models. I'm building image classification, and it's incredible the amount of power that was in my fingertips for being a complete neophyte about AI in general. And so I also said that both, I think, you know, to tell you that, you know, this is kind of what we're doing, and this is the power of it. It's also my get out of jail card, and that if anyone wants to ask me about algorithms or models or training sets, I can say, look, I'm new to this stuff and I'm only learning. But that's the whole point of what we're doing around AI. So the presentation, by the way, if you saw, was subtitled, What Can Einstein Vision Do Apart from Identify Cats? So how many people did the cat rescue trail? Okay, keep your hands up if at the end of it you felt, I really get what Einstein Vision's doing and I know how to use it. I certainly did. I mean, I copy and pasted Apex classes and I got a badge, right, but I did not know what to do. So actually, I think, look, it's a great example, but I'm going to take you through some stuff around how it actually works from a sort of a user's perspective, and hopefully it'll help you understand that, okay? So, just some high-level positioning. I'm going to move through this really, really quickly. But look, AI, and this is the way Salesforce does things. It's like we discovered AI last year, right? Salesforce invented it. That's not the case. I mean, this has been there since, you could go back to Ada Lovelace if you wanted, but really since Alan Turing and the Turing test, and then IBM with Deep Blue, there's been lots of attempts, but I think it's always been this very academic technology. And, you know, literally a big server in a room, and all of that, and okay, how do I actually use it? How is it applied? And I think what's happened recently is we've got to the inflection point where suddenly it's applicable everywhere in so many places. And probably 3 things have come together, right? So the first is we now have data, and thanks to big data, thanks to the IoT in general, with IoT Cloud and Salesforce, we have lots and lots and lots of data, which gives us the ability to take these decisions. The second thing is the algorithms have become much more powerful. A lot more research has gone on into how you train these models and how you make them work. And the third thing is, you know, compute power is just it's exponential at this stage. So in fact, one of the things that blew my mind doing this was I'm basically building these models in Salesforce. I don't know where they're going, I don't know what's happening, but massive amounts of compute are spitting back answers to me in seconds. And so it's available for all of us to do this. So you don't need the massive box that IBM would have had in the past, okay? And we all use this every single day. If you use Siri or you use Alexa, you've got natural language processing going on. All these recommendation engines in e-commerce are powered by AI. The sort of auto tagging of your photos on Facebook, that's all AI. And just like Salesforce has done from day one, Mark and the team were just inspired by the simple innovations that happen in the consumer world and say, can we apply this into a business context? And I think, look, we all know, and this is Gartner validating it, that yes, there's just huge numbers of users. 500 million could each save 2 hours a day using simple AI tools and prompts and applications. That's 1 billion hours of increased productivity. That's 1 billion more hours on the beach or leaving the office at 5 o'clock on a Friday or whatever. I think that's really, really powerful. And that's just, we're still only in the start of it, and that's what it's doing for us. And if anyone's taken those trails, I think it was really interesting to go through the Einstein trails. We're not trying to position this as being super mission critical, strategic decision making taken away from humans and given to computers. What we're saying is the ideal place to apply this is when you have a lot of data about a decision, and typically the decisions are happening a lot. And it's if we can just make every decision a little bit better or a little bit smarter or a little bit faster, that's where the business value really comes at the moment, okay? And so you'll have seen this, all of these features that we're embedding in our CRM tools. We're using lead scoring, we're using Einstein forecasting, opportunity insights, it's very powerful. They're all small little examples to just make a user a little bit better, okay? And I think that's very, very powerful. Where we're going to talk about now with Einstein Vision is more about the platform side of it and what else you can do. So the thing to think about, and again, I'm saying this now as someone who learned this last week, okay? So I apologize to any data scientists in the room that I'm preaching to you, that I'm the one up the front, but look, just, so get everyone on the same page. There's 2 ways to look at this data. You've got your very structured CRM data, okay, where you've got rows upon rows upon rows of very clearly defined metadata to know exactly what it is, okay? And that's one approach, and that's what, for instance, a lot of our lead scoring type tools are doing, forecasting are doing. But where the real interesting piece lies, and what we're going to talk about now, is the unstructured data that comes from voice, comes from text, from social, and also from images as well. Getting computers to understand that is a lot harder, okay? And so, from a technical perspective, just so, because you hear people, and I did this even last week, I was guilty, I throw these words around without really knowing what they mean. You've got 2 distinct types of learning that go on here. So for the structured data, where it's simply about spotting the patterns in the numbers or in the fields, that's where you really talk about machine learning. And that's relatively straightforward for a data scientist to do. What we're talking about for the unstructured data, for images, for voice, for text, is machine learning, where actually it's got to go a lot deeper and not just work within the structure of the data, but spot the patterns in the raw information that's actually being gathered, right down to the pixel level, for instance, if you're talking about image recognition. And so where we're going with Einstein Vision is much more about machine learning, which is kind of the higher end of AI, if you like, from that perspective. Okay? So just saying what it's doing here, and whether it's image or voice or whatever it is, you're going to give it some input data, it's going to understand that, but literally it's breaking it down. If we look at image, it's taking a picture, it's then breaking the picture into pieces, it's understanding the edges, it's going right down to individual elements of a picture, right down to ultimately pixels or patterns in the pixels, things that we cannot possibly hope to see or to understand in image. So that's really what we're doing with this deep learning approach. Okay? So, I mean, AI is hard enough in the first place. And I've sat with CIOs and they'll say, yeah, we're doing AI, and often it's kind of a rule-based approach. And a lot of them, if you talk to CIOs, see AI from the machine learning perspective as just an evolution of the rules and the codes that they write, and it's a cleverer way to do it. I think deep learning is something newer, where the business just wants intelligence, and we're going to see a few examples in a while. I just want the answer of, is my fridge stocked with Coke or competitors' products in there? But behind it, you need, serious experts, a lot of data science, a huge amount of computing power and data and resources that most businesses can't take, okay, or can't afford rather, okay. And just as Salesforce has done from day one, where we democratize CRM and then democratize other areas, we want to democratize deep learning. We want to give this huge amount of computing power and resources and put it in the fingertips of all of you. Doesn't matter what size business you're working with or what size the company is, they'll get it. It's got the hooks built directly into Salesforce, so you can use it straight away. And finally, there's a ton of research going on. I don't know if does anyone follow Richard Socher on Twitter. He's just trying to hire people, and really interesting at the moment. Probably the first time Salesforce has done this. We're just hiring researchers. It's not developers, it's not product managers. It's just come and do interesting research, and if a product comes out of it, that's cool. If not, something will happen down the line. But all of the benefits of the learning and the models and the algorithms and the training is then just coming through the product for all of you to use straight away. So it's, I think, very, very compelling from that perspective. So we announced recently two sort of sets of deep learning. So for vision and for language. And simply because it was a stretch for me and also for time, we're not going to do language today. We're going to focus on the vision piece. Okay? Actually, that's some homework for me. So essentially, there's two services. You've got image classification and object detection. Okay, so let's just look at what both of those do. So image classification is probably then the easier end of deep learning when it comes to image recognition. This is allowing all of you to build custom models to predict anything that you're looking for in a picture. Is it, as you're going to see, is it a picture of a Coke can or a Pepsi can? Is it a crashed car or a non-crashed car? Is it a littered beach or is it a clean beach? Whatever you want to predict, because that's ultimately what this gives you. It doesn't give you the definitive answer, it gives you a prediction and a degree of confidence. Okay? But whatever you want to predict, you can build those models and then embed them directly into your app. Okay, wherever you want to put it. I suppose what image classification is ultimately doing is it's simply coming back with a straight answer. This is a picture of. Okay, it's not trying to do anything within the picture. It's simply saying this is a picture of. For instance, in this case, it's product recognition. This is a picture of a two-door fridge. It's not telling you where the doors are or how many doors. It's just saying this is a picture of a two-door fridge. It's that simple. Okay, and here's the thing, I was talking to someone about this last night. I think a lot of the struggle, and I had the struggle as well, is trying to understand a practical application for Einstein Vision. And when you think about it, there are a ton of processes, business processes, particularly in the field world, and we had a talk about field service lightning earlier, where what the app is actually doing is having the user describe what they see, and trying to convert that into a language that the computer understands. So fields, count how many of this, is that compliant, yes, no, tick, 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 tick. If you think about this thing as a business device, probably the least used element of it from a business perspective is the camera, right? You don't really use the camera for that much in a business context. And that's what we're able to do here, because suddenly, rather than trying to describe it and fill it in a form or whatever, you can literally take a picture of it. And Einstein Vision can understand that and can turn that into useful information, which is incredibly powerful. Just an example of how far this can go, I was talking to some guys at IBM Watson. They can actually predict, or diagnose diseases simply based on your social media profile pictures. If you were to share your social media, your photos with Watson, they could look at things like weight gain or weight loss over time, change in skin tone, how bloodshot your eyes are. Actually, I want them looking at my eyes this morning, and actually make diagnoses that are accurate. So, previously we'd have to describe these things. The camera can just do it. So, actually, there's lots of very practical applications. Now, how this actually works, another pseudo-technical slide. And it's, again, this was the bit where I was freaking out. How am I actually going to do this and show this to Surfforce? Turns out it's actually really simple. Okay, it needs some thought. Like Laura was saying this morning, you got to think about these things and be planned and structured. But the actual how is very straightforward. You will simply create a folder of photos that classify whatever it is you want. Okay, I'll show you an example in a second for a beach, for instance. A folder of photos of clean beaches, lots and lots and lots. Folder of photos of very littered beaches. That's simple. Okay, you create that into a zip file. You pass us to the model, which trains it. And then very simply, you give it a new picture and it spits back a prediction. Is it clean or is it littered? Is it Coke or is it Pepsi? And because it's ultimately an API call, you can have an application pass that image in, and an application then receive the information back as an API call instead. Okay, so that's effectively how it works. Okay, and I'm going to show you that in just a second. Object detection is probably the then taking things to the next step. That's some water here, isn't it? Excuse me. Because what object detection is doing is actually telling you how many and what of any object are in a picture and where they are in the picture. So it's now interacting with the image and giving you the answer back. Okay, so where this is very powerful is, and actually the resolution maybe isn't coming through, that's a picture of like a fridge in a bar or a shop or something like that with cold drinks in it. And this resonates with me because my first job out of college was I merchandised for Coca-Cola. And I basically had to visit 4 supermarkets before 10 a.m. twice a week, and I had to document what was on the shelves, and then in the time that I'd left, I had to restock anything that was out of stock from the storeroom, and then get to the next one on my bicycle as a 17-year-old. And if I had roughly half an hour in each store, 26 minutes of it were trying to document what was there and was it compliant with the planogram, and I had 3 minutes left then to run around and try to stock the shelves. Usually, by the way, with a Stanley knife, trying to cut open the containers and then cutting the bottle and spraying everywhere, and it was a horrible, horrible job. Whereas now, with object detection, I'd walk in, take a picture of the shelves, picture of the fridge, whatever that is, and literally Einstein Vision can tell me how many of one thing are there, pass that back to headquarters straight away, and trigger reorder if necessary. So very, very powerful. I think in that sort of retail FMCG space in particular, it's very compelling. So slightly different approach here, and I'll show you this as well. Effectively, you collect a load of images that would have the object, be it a shape, be it a logo, anything like that, and effectively you then need to go in and draw a boundary around where that is. Very simple, just a little bit time consuming. You then pass that to the model, and then when you pass in a new picture that may contain multiple objects within it, the objects, where's the laser pointer on this? Is that it? Pass it in, it'll tell you how many and of what and where it's actually seeing in that picture. So very, very powerful. And again, because that's there as an API, that can actually start to drive decisions, workflows, processes. You can use that with an Apex, etc. Okay? So, yeah, as I said, I think it's very applicable in that FMCG space. So what I want to do before I go talk about a practical example, if I can, is just show you this. Would it be useful for me to actually go in and show you how it works? How many people have played with this? We've got 2 hands. 2.5? Or that I got you. The cat recognition, yeah, exactly. So let's just go in here. So first of all, this is in sort of, the solution engineers have a tool. Someone's built us a Visualforce page to do a lot of this, okay? But there is also a free project on GitHub, which I'll give you the code for, which actually gives you a UI to upload the data sets and to train the models as well, okay? So essentially, if I take, for instance, I have my beach model here, where I've got literally a label for littered beach and a label for clean beach. So all I would have done, if I go into my Explorer here, is I have a folder that's called beach. This was actually for a model I was trying to build that had 4 levels of classification. And then within each, I just literally, this was Google Images. I went and found lots and lots of pictures of clean beaches. So, you know, the key thing here is you need to spend the time. It's like bad data in, bad data out. If you give it sort of mixed set of images, it's going to struggle. Find lots of different pictures, close-ups, long shots, high shots of what a clean beach would look like in this case, okay? You upload that in, and then essentially, if I just pick here, I've got lots of models, so this is sort of rerunning itself 3 times, okay? I can now go in here and just predict. I can give it any picture, so I gave it one here before, and you can see it came back looking at it and saying, I'm 81% confident this is a littered beach. There's a chance it's a clean beach, but I'm pretty sure. So this is just a sort of a UI way to test it. Obviously, you know, in real life, you'd be passing this to the API. So if I just take this image here, it's going to go away. It seems to be taking, it's just running a little bit slow at the moment. It's going to take about sort of maybe 10 seconds to come back on that. But just while I'm waiting, here's another example, and you're going to see this in a second. So this is actually the live customer example where these guys buy crashed cars, And then rather than sort of trying to guess, we have image recognition going based on how crashed the car is, coming back with a code to say it's a write-off or actually, yeah, you can buy this one or not. So let's just see in the few seconds. Yeah, it's come back and it's saying, look, this is definitely a littered beach. Okay, it's very, very clear on that. So, you know, all you got to do is gather those pictures. So again, there's probably some planning work involved in going and saying, right, where do I get them? How many do I get? Whatever. You can actually see from the model here that it took in 28 pictures of a littered beach and 30 pictures of a clean beach. So it's definitely not thousands upon thousands of pictures. It's 20 and it seems to be working. Obviously, the more you give it, the more it's going to learn and the more accurate it's going to be. And you're going to have situations where can it spot, you know, beach furniture or bucket and spade is different from an abandoned can on the beach, whatever. That's all about how you classify it, okay? And then just from the, is this working? Please let me in. Go on. I think I need to be on VPN for that tool to work, so this version of it. So I can't show you the labeling, but essentially you upload the pictures, you draw the box around it, and that's it, it's trained on. So you can actually see that here, for instance, if I go into my object detection, I have one very much based around our sort of a litter story of trying to spot whether we've got, for instance, cans or bottles. So in the same way here, I can go in and say, if I take my litter type, this being a demo environment, things like that happen. But for instance, here is a picture of cans. And again, this will take a few seconds, but it's not just going to say, yeah, that's a picture of cans. It's actually going to come back and tell me how many and where they are. So, please. For some reason, it's running slowly. Let's see the raw results. Let's come back in a second if that will, there you go. So look, it's literally, I mean, that's pretty good off 20 images of cans. It's only missed 1, 2, 3, 4. Okay, so again, I'm not a data scientist, not an expert on exactly what I needed to do to train a model. I just went onto Google and said, give me pictures of cans. And on that basis, it's found them. And actually what's kind of cool, and you're gonna see it in a minute from the demo that Charlie and I are doing later, is it will actually even spot, for instance, crushed cans. So it's going to go away. That's actually just the screen needs to refresh, but it can spot deformed, rusty, all of that. Okay. So just really quickly, let's talk about an actual example. And I'm really proud of this because it's a European spill glass example. So it's this company, Auction Nation. Now, I don't know if you know this or not, I imagine you do. I sometimes think what Salesforce people do is they incite a fair amount of cynicism in our broader Ohana about all of our marketing level stuff, and that's cool. But whenever we launch a new product, like IoT Cloud or like what was Wave Analytics, product management work really closely with the launch customer. So remember it was GE when we had Wave as a product, for instance. And they get direct access into product management. For IoT Cloud, you know, Charlie builds a lot of these awesome demos that Coca-Cola get to see or whatever, and you know, there's a lot of connections. Auction Nation is a small company in South Africa. It didn't get any of that support. It was one of our account executives working one of our pre-sales people, Philip Moore, to just use the technology that's there today. So this is kind of what's in the wild. This wasn't sort of, you know, a co-development opportunity with these guys. So just in 10 seconds what they do, probably fairly obvious from this, they buy crashed cars from junkyards. Okay, and then sell them at auction, but sell them as is. So they're not like, you know, Arthur Daly, if you're old enough to remember that. They are saying, this is a crash car, you are buying it was crash level 4, crash level 2, whatever. You're buying it for spare parts, you're buying it because you're confident you can fix it. So the challenge they had was to buy the cars in the junkyard. Before now, you know, there's lots of cars, the buyers are really important to that business. They were physically taking pictures, sending them back to headquarters where someone would look at them and say, yeah, I think it's a 3 or it's a 2 or whatever. It was a long process, it was slow, they couldn't buy as many cars as they needed. They always had problems having enough inventory to auction. So what they've done now is combine, this is where you can see our marketing people worked on a slide for me, you know, Auction Nation working with Einstein, putting all that together to get this type of application where now a business user can simply scan in a couple of pictures of the car and it actually comes back with that prediction about exactly how damaged it is, which is very, very powerful. So you kind of saw the screenshot. I was a little concerned that things were taking time to run. So they trained it. So basically they had code 2 was just a used motor vehicle. It was a bit pranged, but you could drive it. And then 3 was sort of, it needed a fix up. And then these are their codes. I don't know why they've got 2 code 4s, but they do. But you can see over here, it's actually spitting back that that car is definitely a code 4. That's a write-off. It's like, if you look at it, 53 and 44%, no one's going to buy that car. So that was just automatically decline, refuse, no human intervention needed. But where you get over here, if you look, the system isn't confident enough yet. We haven't trained it enough. And this was off about 1,000 images to say, look, it could be code 4, it could be code 2. Workflow identifier to say, actually, we need that person back at headquarters to have a look. They would actually be notified in that case that actually they need to make the final decision. So when it could be confident, it would take a decision. If it wasn't, it passed it on to another person. So, you know, it's something that we put together very quickly. We built a demo, and we were kind of like a lot of Salesforce demos. We're like, God, this works as long as you stay within the boundary. We go to the meeting, and the guy from Auction Nation goes, here's a folder of 100 cars. Let's go through them. These are the ones we actually train our reps on. Is it a 3 or is it a 4? So we were like, oh God, okay. We passed it in, and it actually worked. It hit exactly what they said it should be every single time. So off, you know, very little work. And again, this is the point. And something I was saying to Sean last night, you're going to see another demo in a minute where I'm going to end the session. I'm going to come back in a while. We've got people working, trying to identify how littered beaches are. They've got data scientists who've been working for years and have managed to get to a 40% level of confidence in its prediction. Muggins here downloaded 50 images of a littered beach, put it into Einstein Vision, and it came back with about 80% with zero effort. Right? So the speed at which we can do this is just phenomenal. I think it's about, frankly, people like yourselves spotting the business opportunities to apply this technology. Okay, so it's not just about cats. It can be about crash cars, it can be about brands. There's lots of different things where it can work. So yeah, so that was that. Oh, you can just see here, so it's giving you the probability each time. They were also using object detection to figure out what brand of car it was and to spot the logos. So it was spotting the fact that it was BMW, and it was 80% confident of that. And the tool that actually I didn't get to show you, but if you want a UI, because obviously it's all calls, so you do a command line. If you want a UI to actually upload the images to train it, I'll share this afterwards on wherever's the appropriate place, but that's a GitHub project where all the code is there, and then you can play with that. I've been told to say it's totally unsupported, you're on your own, best of luck, but it's basically how I sort of built a lot of this demo today. So, I'm more or less on time. That's a thank you from me. Are there any questions not about the actual algorithms or anything like that? I'm happy to take them as well.
When did you see the offline version or the non-internet version being actually a usable state?
I frankly just don't
Just
know.
personally, just thinking.
I mean, look, let's be honest. I mean, we announced this, you know, last year. I think we're moving pretty quickly, but in terms of how far that will go, it actually don't have to do at the moment. Sorry. I'll check for it. Right at the back, Ellie.
Can we do multiple things within the same rules? So like you had obviously object identification and image classification.
Yeah.
Can you have like it picking up loads of things at the same time?
So interestingly, at the moment, each model kind of does what it does, but Richard Socher put out a blog post about 2 weeks ago where he's built an algorithm that actually does 10 things at once. So it's doing image detection, and then it's doing sentiment, like to spot text, and then it's doing the sentiment analysis on the text, and then it's doing intent on that. I think he calls it his DECA algorithm or something like that. DECA NLP, thank you, yeah. So we're getting that way. At the moment, each one is kind of like, they are distinct models in their own right.
It's
Yeah.
possible for
Yeah.
the future to be.
I think it's the future, but also it's a case of you need to think about, like, am I doing image classification? Do I just want to know if this is a picture of a clean or dirty beach, or a crash car or not a crash car? Which is different from, I want to know, and you're actually going to see this in our second demo, how many items of litter are on the beach, right? That's object detection, which is separate. So you almost need to think, like, what's the use case? Time for one more, maybe? One more? No? Yes? No? No?
Yeah.
Carrie's in charge here?
Yeah, one more.
One more. I saw a hand in
Then
the
you're
back.
coming
so-
back for another round.
Yeah.
I've got a very technical question. So what was the most challenging part of setting this up?
Uh,
Getting your head around it.
It was our conversation about
No, I think probably thinking through the use case of the first one. So you'll see, for instance, on the beach one that we're going to do afterwards, it's kind of like, when you go there, it's like, it's not a lizard beach, it's just got people on the beach, or it's buckets and spades, and therefore trying to figure out how you actually classify that and get them in the right orders is probably challenging. I mean, this was a demo, so it's not mission critical whether it works or not. I think you probably do have to be very careful about picking the images. I would imagine, for instance, for these Auction Nation guys, they're not going to go on Google and find crash pictures of cars. They will have someone take the official standard, right size and shaped image, because for instance, you'll see with the litter one, Coke cans, they can get rusted, they can get battered, they can get deformed. So how do I give it enough of those that I can still know what is Coke, right? So there's a lot of challenges around there, but I have to say, genuinely, I'm super impressed from what I've given it, how accurate it's been, and I'm happy to show people offline as well, just some things around it. Okay. Cool, thank you.